So we want to begin our very last unit in this class, which has to do with correlation and regression, linear correlation and regression. So in section 10.1, we're looking at specifically what's called correlation of two variables. So the idea is you're going to have an x variable and a y variable. So x is going to be some characteristic with a quantitative measurement, and y is going to be a characteristic with a quantitative measurement. Maybe let's say x is, for example, weight. And let's say y is height. And let's say we're talking about weights in pounds and height maybe in feet. And let's say our weights are starting, let's say, here at 100, 120, 140, 160, 180, 200, 210, 220. So those are our weights, and over here we have our heights. This is going to be in feet. This would be 5 feet. This would be 5.5 feet, 5.5 feet. This would be 6 feet. This would be 6.5 feet. And let's say we have some data points here. Well, let me get this to work. So we have a data point here. No, that's a bad place. Let me back that up some. This person would be like 110 pounds, right? And 5 feet tall. Let's say we have another data point here. This person would be like 140 pounds and 5 feet and almost 5 feet and a quarter almost. Not quite. And then let's say someone's 160 pounds and they're 6 feet. And someone's 180 pounds and they're 5 3/4 feet. And someone's 200 pounds and they're between 5 3/4 feet and 6 feet. And someone's 210 pounds. 210 pounds and 5 3/4 feet. And let's say someone's 120 pounds and they're more than 6 feet. So as you look at this plotting of points, this is called a scatter plot here. This is called a scatter plot. There seems to be this kind of relationship between the x and the y. Notice as the x goes up, the y goes up. You can kind of imagine that maybe there's this line. There's this line kind of that the points follow. They don't follow exactly that line, but they approximately follow that kind of increasing line. But there seems to be this kind of linear relationship here going on, that as the x increases, the y increases. So we use something called the Pearson correlation coefficient. That's what we're going to talk about today. The Pearson correlation coefficient. We give that a letter called R. And that is a statistic that measures the linear relationship between the two variables, the x and the y. So we're going to give you a formula for that later, but first we want to talk about different situations for R. So facts. So we said R is the Pearson correlation coefficient. It measures the relationship between x and y. So some facts. So this is facts about correlation coefficient. So we call it the Pearson correlation coefficient, but for short, we'll just call it the correlation coefficient, just for short. Facts about the correlation coefficient are, number one, R is always between -1 and +1. The correlation coefficient is always between -1 and +1. Number two, if R is exactly equal to 1, then you have a perfect positive correlation. So what does that look like? Well, let's say you got some points, and if the points are lining up exactly in a straight line and they're moving in an upwards direction as you go from left to right, if the line is increasing as you go from left to right, we call that a perfect positive correlation. So perfect means that things line up perfectly, the points line up perfectly, and positive, that means that the line is moving in an upwards direction as you go from left to right. So anytime you have when you calculate a correlation coefficient of 1, that means you're going to have this increasing line and all the points line up perfectly. Okay, number 3. Let's say your correlation coefficient is in between 0.4, so it's bounded below by 0.4, and it's strictly less than 0.7. So greater than or equal to 0.4 and strictly less than 0.7. We say that this is I don't want to skip over something. I forgot something. Let's not do that yet. If R is greater than or equal to 0.7 and strictly less than 1, then you have a strong positive correlation. So if you calculate the correlation coefficient and get it from 0.7 to 1, that's strictly less than 1, but greater than or equal to 0.7, that would be something like this. So you got some points, and generally the points are increasing in a direction from left to right. So if you were to draw a line that tries to interpolate those points, that line would not pass through all the points exactly, but those lines would roughly follow. Those points would roughly follow that line. So it's strong because the line gets pretty close to the points. So strong means the line gets pretty close to the points. And it's positive because the line is moving in an increasing direction from left to right. It's going upwards. Okay, let's do a number 4. If R, the correlation coefficient, is greater than or equal to 0.4, but less than 0.7, then you have what's called a moderate. It's not strong, it's not weak, but it's moderate positive correlation. Should be 2 R's in correlation. I keep leaving out the second R for some reason. So what would that look like? Well, that would look like you got a bunch of points. Something like that. And you can see that they're kind of trending in a kind of linear formation, but they're more scattered out. And they're trending in an upwards direction from left to right. So maybe something like this. This would be where you have maybe a correlation coefficient that's between 0.4 and 0.7, greater than or equal to 0.4 and less than 0.7. So moderate means, okay, so the line doesn't fit the points super well, but you can generally see it's kind of taking a linear formation. And it's positive because the line's increasing from left to right. Okay, number 5. If R is exactly greater than 0 and less than 0.4, then you have a weak positive correlation. So when your correlation coefficient R is greater than 0 and less than 0.4, you have a weak positive correlation. So that means the points are going to be kind of spread out. Maybe like that. I know I erased a few of these. So you can see that the points are kind of trending not very well in a line, right? You can imagine there's maybe a line that kind of follows those points. But the line doesn't follow those points very well. They're kind of spread out all over the place. But if you look at the line, it's still trending in an upwards direction from left to right. So it is positive. It's a positive correlation, but very weak. Okay, what happens if R is 0? If you have a correlation coefficient of 0, if R equals 0, then you don't have a correlation. Then you have no correlation. That means just the points could be all over the place. Something like that. That could be no correlation, right? There's really not a line that sort of interpolates the points. Points are just in a bad place. Let's say number 7. What happens if R is less than 0 and greater than negative 0.4? Yeah, so correlation coefficient can be negative. Then that means you have a weak negative correlation. So a weak negative correlation would be something where your points are kind of doing maybe something like this. So if I focus here, what's in this little window right here, you can see that the points are scattered out, but they're kind of following a linear pattern. They're trending this time downwards from left to right, a decreasing direction from left to right. So you can imagine there's a line that interpolates those points. It never is going to get close to passing through them, though. It's not going to pass through all those points, and those points don't follow the line very closely. So that's called a negative correlation when the line decreases, and it's weak because the points are pretty scattered abroad from the line. Okay, what about number 8? If, let's say, R, the correlation coefficient, is less than or equal to minus 0.7, but greater than negative 1.0, then in this case, I think I left one out. My bad. Let me go back and delete. If R is less than or equal to negative 0.4 and greater than negative 0.7. Okay. If r is between negative 0.7 and 0.4, then you have a moderate negative correlation. So the strength of the correlation is moderate and it's negative. So I draw a little window here for that. You might have some points that are kind of, well, maybe make them blue. Maybe your points are something like this. You can definitely see they're following kind of a linear pattern. You can see there's definitely a linear pattern here, and it's, if you were to draw an interpolating line, it might do something. Well, that's a bad interpolating line. Let me try that again. Do something like this. So those points are hugging that line a little bit more tightly, and you can see that it's negative because the line is decreasing from left to right. So it'll be a negative moderate correlation. I need to make some space for my next one. Number 9, I'm going to put it way down here. Number 9, what happens if R is less than or equal to minus 0.7 and greater than negative 1.0? Then in this case, you have a strong negative correlation. Okay, so if I draw a little window here and I have some points, and we try to interpolate those points with a line, you're going to notice that the points are going to hug that line pretty closely. So that means you have the strong correlation. And negative means that as you proceed from left to right, the line is decreasing. Okay, we got just one more now, one more situation. What happens if your R, your correlation coefficient, is negative 1.0? That means you have a perfect negative correlation. Perfect negative correlation. So if I draw a little window here with some points, and I interpolate those points, perfect correlation means that the line will pass through every single point. That's what perfect means. So perfect, the line passes through all the points, and negative means the line decreases from left to right. Okay, so we have these 10 different cases here, I guess. Well, actually 9, because negative 1 to 1. The first fact just tells you the correlation coefficient only goes from negative 1 to 1. So some other terms you might want to hear is, anytime you hear a negative correlation, another way to say negative correlation, you'll hear this term, X and Y are inversely related. This is just another way of saying there's a negative correlation. X and Y are inversely related. And if there's a positive correlation, you'll hear this said in a different way sometimes. You'll hear sometimes that X and Y are directly related. Okay, so we've talked about this concept of the correlation coefficient being either positive or negative and being between